Well, hello and welcome YouTube. Mr. Robbins back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Alright, step on aside in the last couple videos that we've done regarding circles with angles and relationships and things like that, we will continue just more of a review of what you saw before. I believe 21 practice problems, and let's revisit the formulas that we had so far. Now, I did this worksheet, I should say, I did an answer key for this worksheet for my students earlier today, just rummage through the problems. Not a solution guide, that's what this is, but just to get the answers, and without a calculator, mind you, so I can't guarantee if I got them right for my kiddos, but, you know, it took me like 8 minutes or so, and they're like, what? Basic idea is, you know, it's not going to take me 8 minutes to do this video, though, because I want to explain it to you guys. So just understand that while they can be done quickly, you work it with it at the pace that you need to. So I'm going to do this here. Before I get started, I'm going to skip this portion. Well, I think we get into these kinds of problems later when it comes to sectors and segments and such. Let's look at the vocab, some words that you're going to have here that I will say later as well. The diameter is kind of this purplish one. I'll try and match, not perfectly, but I'll match colors as best as possible. Diameter is the longest chord in a circle, and a chord is any segment going between two endpoints, such as chord would be this guy right here. Radius would have been this guy right here. Now, radius is not a chord because it does not go among two endpoints. And then there's secant, which does hit two endpoints, but it is a line. So a secant line is this guy right here. And then you have the tangent line, which touches right here. A tangent line, and I'm not actually writing sideways, but I'm trying to. A tangent line is a line that touches the circle exactly at one point. And it's actually hitting the diameter right here, and it's creating what's called an inscribed angle. That inscribed angle right there. And it's a 90-degree angle because its intercepted arc is the semicircle. All right, let's look at what central angles are, and I'm going to be very quick with this as I was with my students, just a basic toolkit. The relationship between a central angle's measure and its intercepted arc is they are equal. I'm sorry, let me put an A here for the arc. If the angle is X and the intercepted arc is A, X and A are the same value as far as degrees go. They are exactly equal. An inscribed angle, an angle that's on the circle, if it has an intercepted arc A, its relationship is such that the angle is half the measure of the intercepted arc. Or, of course, if you double the angle measure, you get the intercepted arc right there. Sorry, I noticed I'm covering it right there. That's going to happen quite a few times with me here. All right, so there's that one as well. Going to move forward. A lot of the other things have to keep in mind in inscribed angles. Now, I've mentioned them before, and I think they're in the previous videos, so this will go fast as far as formulas go. So, and I'll do these examples super fast as well. I guess I have more than 21 examples. All right, so recap. I have an inscribed angle right here as well. Note, these points A and B, any of these would be inscribed angles like this, right? Inscribed angle, inscribed angle, inscribed angle. Well, so is this right here. As long as that line is tangent to it, it is still the same measure as any of these other ones. And how do these measures work? It's half the measure of its intercepted arc. That X is half that of A, or of course, if you double the X, it equals A. And I say both because I use both. It depends on which one you're trying to find. You're trying to find the arc or the angle measure. Case in point, well, not case in point, but here you're trying to find the angle measure. Its intercepted arc is 130 degrees. So the measure of angle KLM is half of 130, which is 65 degrees right there. These are but smaller examples, I suppose. I think the ones in the other diagrams may be more complex, or they're at least shuffled. Two secants meeting outside the circle. Well, actually here, these three all run in tandem to me, essentially, together. I know there are more streamlined formulas that you can put for something like this one here. I'm going to treat them all one the same, at least for my kiddos. The idea is this angle is outside of the circle, and its intercepted arc, if it were an inscribed angle inside the circle, would have been significantly smaller. Now that it's so much bigger, how much bigger did it get than the inscribed angle version? It got that much bigger. So we're going to take this arc away when we determine this angle right here. If this is some angle measure X, this is arc measure A and arc measure B, or this is some angle measure X, arc measure A, arc measure B, this is some angle measure X, arc measure A, arc measure B, which is defined by the major arc here and the minor arc here. All of them have the same formula basis. The angle measure is half the difference of your two intercepted arcs. This applies here. This applies here. Again, there is a more streamlined version here. The idea here is that a plus b is 360. That's a big highlighted concept of that. Now, if you double x right here, that would equal the difference of your two guys right there. So one or the other. All those run the same. So as a first example right here, and these aren't even the problem sets, but as a first example right here, if I want to find the intercepted arc value right there, I'm actually going to say if I double 40, then you get the difference of the big arc minus the smaller arc right here. So 80 is x minus 80, or x is 160. And yeah, see, I'm going to go fast on these problems for the most part whenever I'm able to, especially on these little example versions. If the algebra is all that's left, I'm saving that. X is half the difference of 141 and 61 right here. So that's half of 80. You can see why, and these aren't the problems I was talking about here when I said it took like 8 minutes on it. You can see why I'm saying that this takes me very little time to just take care of. Once you have the setup, it's really just fast algebra. Again, there's a different version of a formula here you can work out, but what I'm going to do with you guys is just the same version to say if it's an angle outside the circle, you take half the difference of one and the other. But you got to find the other in this case, and what we can understand is this part of the major arc is 360 minus 110, which is 250. So x is half of 250 minus 110, which is half of 140, which is 70. Now, for those who still believe I'm blowing smoke in any sort of way, I'll just bring mention to the light of x is also 180 minus 110. You can take 180 minus this small value right here. You'll get the same answer. Okay, the last one is angle formed inside the circle, and let's say that we were referring to, say, this angle right here. Now, there's a vertical angle pair right here, so whatever this angle is, this is. And they may not have the same intercepted arc, but they will have intercepted arcs. And the idea is that if you added these two intercepted arcs together, it would be equal to, if you place this as an inscribed angle, say right there, on right here, it would be this plus that. So the angle measure is half of the sum of the intercepted arcs right there. So if this is your angle measure x, and this was a and this is b, this is x is half that of a plus b. Or of course, if you double your angle measure, you get a plus b. So if I wanted to get x right here, this angle measure, that should be half. Whoopsie, half of 43 plus 41. What's half 3 of 43 plus 41? It's 42. So x is 42 degrees, or 42 right there. This is 42. That would also mean that's 42 right there. Both of them are the same. Doesn't matter which one's kind of which in that regard. Okay, and that's our toolkit. And I'm going to continue on those with these problems here, as they could get more complicated with drawings. Now, there's a 1 through 6 that really highlights central. It says central angles, but that's not a central angle. But there's a 1 through 6 that starts right here, and then another 1 through, I believe, 15. So I'm going to go through all of these. Very little room, but I'm going to rummage the algebra super fast to solve these. Try and keep up. It's just a little review for my kiddos here, as we're doing everything from central angles to those angle relationships. All right, we're finding the missing intercepted arc measure here for the central angle 123. That means that is also 123 degrees right there, because central angle measures and their intercepted arcs aren't equal. All right, this question mark right here, we got to find this guy. Now, this is just some measure that completes the circle with the 75 and this unknown guy right here. Well, this unknown guy right here is the intercepted arc of this inscribed angle 95. If I double 95, right, the measure of the intercepted arc would be double that of its inscribed angle. I get 190. So this is 360 minus the sum of 190 and 75, or 360 minus 265, which is 95. As well, it's 95, much like that angle's 95 right there, which is probably unrelated. Because that's not an it's whatever. Measure of arc EFC. Now that becomes a major arc right there that goes all the way around here from E through F to C. Okay, they show congruent things right here. Those are equal. I mean, okay. But I don't really care. What I do have here is a diameter, which means this part's a semicircle. This is 180 degrees right there. Technically, this part right here would also be 180 degrees in and of itself, that guy. What we need to find out maybe is what that angle measure is right there. I mean, look, whether we're talking about this one or the other one, these are vertical angles here. I should do different arc marks. And we can make a linear pair. This is also a diameter right here. So 126, 180 minus 126. That's 54 degrees right there. Central angle, which makes that 54. So 180 on the semicircle plus 54, or 54 plus 126 plus 54. That's 234 degrees. I have hiccups. Let me pause this for 1 second here. Okay, I'm back. Sorry. Generally get my TMI. Generally get my bodily functions here because I generally record right after eating. And man, I scarf down food. You don't even know. All right, number 4. So we have the 62-degree inscribed angle, which has these endpoints. Now, the central angle also shares the same endpoints. You can kind of work this in 2 ways. You get the same answer. Its intercepted arc, the inscribed angle's intercepted arc is double that, so 62 times 2, which is 124. And then the central angle shares that intercepted arc measure, which is 124. And that's really what I was going to say. An inscribed angle and central angle that share the same intercepted arc means the central angle should be double that straight up. So you can do that. But it should be 124 degrees right there. Okay. Number 5, okay. So with these ones here, this is, I haven't done too many of the problems with my students on these right here. There's nothing wrong with it. It's just that you have to now quantify things and doubling up, I suppose. I'm trying to think if there's, you can do different things all depending on what. So let me kind of show you 2 different forms. I'm likely just going to do the algebraic form each time though. This is an inscribed angle, and this is its intercepted arc measure. So, well, first of all, as far as just writing an equation, you can either say the inscribed angle is half the measure of the intercepted arc, or you can say that doubling the inscribed angle gets you the intercepted arc. That way, one way or the other, I guess that is the other way I was talking about when I came to taking half it. If you're too confused on what to do here, the idea is you would have to quantify doubling it. I guess that's the big point I wanted to make. I'll go ahead and do I'll do both. So in this first one here, if I take half of 192, I get 96. So 31x plus 3 equals 96. Subtract 3, divide by 31, you get x equals 3. Alternatively, if you have this distribution here, 2 times 31, let's put it over here. 2 times 31 is 62x, and then plus 6 is 192. Subtract 6, divide by 62, x equals 3. So either or. The basis that I was going to bring about, though, was that if you wanted to completely ignore what expression was here for a moment and just say, it's just, I don't know what it is, you can first figure out what that thing is by taking half of 92, which is 96, and then say, okay, this is equal to 96, which is ideally, I guess, that top equation right there. So I'm good with using what it is I'm trying to find. If I'm trying to find an inscribed angle measure, then I'm going to talk about taking half of this. If I'm trying to find an intercepted arc or something with an x in the intercepted arc like this one right here, then I'm going to double the angle measures that I'm referring to. Okay, so number 6 right here. We have, if you wanted to go, I'll just go with the this right here. This is a diameter right here, which means we have supplementary bits. So if this is 140 degrees, then this is 40 degrees. And this is a central angle measure right here, which would be equal to its intercepted arc. So 6x minus 8 equals 40. If you add 8 and then divide by 6, you get x equals 8. And I believe they're just asking to solve for x, not find the actual arc measure. Let me see if they... because I find the values of the missing arc or find x. Yeah, so x equals 8 in that scenario. Okay, that was the first 6. Let's keep moving forward. I got 15 more problems to do, and that took not too much time to do all those. Let's see if we can finish within the half hour. All right, so this question mark right here, this is our unknown we're trying to find. It is I'm going to put an x whenever these things show up here. It is the bigger intercepted arc with the angle on the outside. So if I double my angle measure, I will get the difference between big arc and small arc right here. 88 is x minus 65. Add 65, you get x equals 153 degrees right there. Again, the angle 44 should be half of 153 minus 65, and it seems like that's what that pans out to be. Number 2, this is an inscribed angle with an intercepted arc of 146 degrees. So the measure of angle, QRS right there, is indeed... I'll just put x's each time. How about that? Anytime there's a question mark, I'm going to put an x instead of the big guy. But it's half of 146 which is 73 degrees. It depends. It depends on if I have to do more than one part in the problem. I can't remember. For the most part, I'll kind of label the diagram whenever I can. Okay, we're trying to find this unknown here, and again, I'll just be calling it x in some situation. You know what? It's probably worth doing it that too. I don't want to say measure of angle UVT each time. I can, but if I label an x, that works. They put a question mark after all. All right, so the x here, it is half of the sum of 175 and 53, like that, which is half of 228, which is 114 degrees. All right, and yeah, literally I'm going through these problems here. Unless there's something to talk about with strategy and like saying these problems look like we can do this, that, whatever, I'm going to work that. All right, two ways to solve this. I'll say straight up, you can do 180 minus 120 and you'll get 60, and that is the answer. I was dealing this with one of my students earlier today and kind of showing how it is 180 minus that number. If you don't know that, and if you want to work the thing out this other way, it's what I'm going to probably stick with my students with, which is any angles outside of the circle, half the difference of big minus small. So this is going to be, if that's my unknown, this is going to be half of, by the way, big is 360 minus 120, which is 240. So half of 240 minus 120, which is half of 120, which is 60. So it's that same answer that you saw. Okay, we are trying to find this unknown right here. The angle's inside the circle right here, and we have these two intercepted arcs here that we can add together. So if I double 120, I will get the sum of those intercepted arcs, x and 60. 240 equals x plus 60. Subtract 60, x is 180. That is, I guess it's a semicircle then, right? I guess that means this is a semicircle and this is some sort of diameter. I guess. You can't be wrong. We're trying to find this guy right here. Now I have an inscribed angle with its intercepted arc that should be double that of 76. So 2 times 76 is 152. So this should be 360 minus 152, which is 208. No, yeah. 208 degrees. Alternatively, in case I was wrong, you can use the linear pair of the 76 right here. 180 minus 76 is 104, and then we can double the 104. 2 times 104, and we should get 208, because this is now the tangent line angle, is now the inscribed angle of this big intercepted arc, which is that one. So one or the other we get there. Number 7, the angle is half the difference of 129 and 61. So this x here, x is half of 129 minus 61, which is half of 68. Yeah, I'm really bad at my addition subtraction math. Like the past year plus, I've been really bad at that. 34 degrees right there. Number 8, once again, half the distance difference of the measures there. Some x. X is half of 175 minus 57, which is half of 118, which is 59 degrees. Sorry if I'm going really fast. That's nature of the beast. All right, number 9. Same issue as before. What did we do 110 before? I think we did on a different page. You could determine, so the angle you could either determine as 180 minus 110, or you could do half of, what's 360 minus 110, 250? Half of 250 minus 110, which is more conventional for angles outside the circle, but if you know tangent lines work with this, you should get the same thing right here. This is half of 140, which is 70, and this is 180 minus 110, which is 70. So where you have an equation that says 5x plus 10 equals 70, either or. So subtract 10 from both sides, you get 5x equals 60. Divide by 5, you get x equals 12. That's they don't really put the degree symbol around this or doing anything, but I'll go ahead and put the degrees to be safe. All right, number 10, solving for x here. We have an inscribed angle. Here's this intercepted arc, which is double that of the inscribed angle, or the inscribed angle is half that of the intercepted arc. Because I'm trying to find the x here, I'll go ahead and say half. The x, 7x minus 10 is half the measure of its intercepted arc. So, I don't know where to write all this. I'm sorry. So we'll do 7x minus 10 equals 60. Add 10, 7x equals 70, divided by 7x equals 10. 5 more problems, and then we are good. Oh, I'll definitely finish in the half hour. Are you kidding me? All right. The x is inside here, so the same kind of thing. I'm going to say that this expression, I should have a little more room here. This will be half the difference of the 140 minus 48. So this is half of 92, and that's 46. So subtract 13, divide by 3, x equals 11. All right, once again, we're going to take, well, this angle is half the difference of these two, but because the x is up here, I'm going to go ahead and double the 50. So if I double 50, I will get the difference of 12x plus 8 and 4x plus 4. Now, the thing you have to do here is you definitely have to quantify the 4x plus 4. Might as well quantify both just to kind of be safe. But I'm subtracting this whole angle here, right? So you're subtracting 4x and you're subtracting 4. So 100 equals 8x plus 4. Subtract 4 from both sides, divide both sides by 8, you get x equals 12. I should get in the habit of putting that degree symbol there in those. It's hard because they really should be putting degree symbol around here, or at the very least putting it on the 10, because then I can plug in the degrees there as I kind of need to. Otherwise, it's not a degree measure, right? Who knows? Maybe they're talking about a length. All right, number 13. This is an angle inside, so 60 is half the sum of these two right here. Or if I double 60, I get the sum of these two. And I got a lot of room underneath this time. So doubling 60 will be the sum of 5x plus 15 and 55. Rest is algebra. That's why I'm going fast on these parts there. These aren't the hardest of the problems. This is just a good old review to mesh all of these things together. You're hearing the same thing over and over, so I hope it's connecting in some sort of way. X equals 10 degrees. All right, we have what appears to be a triangle, but we don't know anything about isosceles or semicircle or this or that. With 38, I don't know if when I did the answer key, I don't know if I got this right or wrong at the time, because I didn't know if the 38 was in reference to the intercepted arc or this angle right here. Now I'm starting to think it's the angle, and I don't know if I said that right or, you know what, I might have done that at the time. I might have said it was 38 degrees. Okay, so the point of this problem is going to be this. I know the answer, but it's going to be this. These are endpoints to this inscribed angle right here. That means its intercepted arc is right here in red. Well, guess what? This thing right here in blue is also an inscribed angle to the same intercepted arc right there. This shares the same inscribed angle as this. Do I still have the same drawing from earlier when I was scribbling? Nope. I was scribbling all those inscribed angles. I said, you're an inscribed angle and you're an inscribed angle. The purple and blue inscribed angles share the same exact endpoints. That means they share the same exact intercepted arc. If 38 is the inscribed angle of what's in blue, x is 38. Because they're both, all inscribed angles of the same intercepted arc are congruent to each other. X equals 38. And I don't need the degree symbol because it shows the little degree guy right there. You could say, let's double 38 to get 76, and then half of 76 is 38. You're back to where you were. Okay, and last one, number 15 right here. Once again, I do have another, if it matters for the sake of the problem. I do have this x right here with this, it's an inscribed angle with this intercepted arc. Now, on the other hand, I have this outer angle right here that goes out to this intercepted arc of 160 and the smaller intercepted arc right there, which we don't know. That intercepted arc is the same one I need for x. So let's operate in green first. 35, if I double 35, I will get if I double 35, I will get the difference of 160 and this unknown one, I'll call this y, and this unknown guy right here, intercepted arc. Now x is half that of y, so whatever y is what we're going to do there. Let's add y to both sides and subtract 70 from both sides. You'll get y equals 90. So this is a 90-degree intercepted arc to this x right here. That x is going to be half that of the 90, which means x is 45 degrees right there. Okay, and that's it, and that's all. And yeah, there were definitely more challenging problems in the previous ones, but they were also more focused when it came to what we were doing. But that'll be it for this one, guys. This is Mr. Robinson cracking this thing down, getting this thing done in 25 minutes time. Thank you so much for watching. Take care. I will see you in the next one.